Okay guys, welcome back. Today we're going to start looking at ecosystems, and this semester your final project is going to be to build an ecosystem, to take the different labs we're working on and build an ecosystem. This is an example from a student from last year, I believe. In any case, what we're going to be thinking about is taking these different labs and applying different kinds of behaviors. So just to identify some of the behaviors in this one, the little white guys are flocking together. We're going to do a lab on flocking. All of this is coming out of Daniel Schiffman's book, The Nature of Code. And so we've already begun to work with vectors. We're working with attraction. You can see that predators and prey, we have both attraction and repulsion going on. We have different kinds of animals. For instance, these little snake guys chase the white guys, and if they grab them, they get longer if they eat them. These blue guys have arms that extend out, and they try to get different kinds of creatures, and if they get them, I don't know if they get bigger or what they do, but they try to eat the little white guys in particular. But these are all behaviors that are built out of the different kinds of labs that we're going to be doing this semester. By the end of the semester, you'll have your own ecosystem, and you will understand JavaScript really well. However, what we have to be paying attention to is that when we do an attraction lab, for instance, now you have to think about how do I apply that to an ecosystem in the form of some kind of creature. Obviously, attraction kind of lends itself to predators and prey. Here's another example. In this example, this student has got all kinds of different behaviors. This blue guy over here is putting out poison pellets. He has flocking. If these guys go through the poison pellets, they lose health. Creatures can die. Creatures can mate and spawn. Let's see if we can see two that are reproducing. If they have a pink bond to go between them, they go close together and then they burst apart, and they have all kinds of little baby creatures. And I don't see that happening anywhere right now. It just sort of happens randomly. You can see different kinds of behaviors. Predators, prey, defenses, reproduction, dying, being born, all these kinds of things create an ecosystem. Okay, so now we're going to look at some examples of just this attraction. I applied it in several different ways, just as kind of an example. This particular lab is using both attraction and it has repelling. There's a guy in the middle here you can't see, and the balls are retracted to him until they get to a certain point, and then they're repelled. So they create this kind of donut, and if they get pushed off the edge, they shoot around. So we have all this interesting kind of interaction, but we have these really nice movements that we can see, and this is an example of taking the concept of attraction and applying it in some way. Okay, here's another example. Now this one's a little bit different. I just tweaked it a little bit. This is kind of weird. It's doing something I completely didn't expect. What's going on in this one is that inner circle. Remember we said in the last one the movers got closer and closer to the center point, and then all of a sudden if they got too close they got repelled away, so you have this back and forth motion. Well, that inner circle, the radius of that zone, I changed into a variable, and it gets bigger and smaller, and as a result some of the movers just go in circles around the center point. Other guys keep going back and forth. And so I began thinking about that, and I said, I wonder why that's happening. It wasn't immediately clear. So what I did is I changed it so I had fewer movers, and I changed it so I could see their path. So that's in the next one. Okay, so in this one you can see there's only two movers, but we can see they approach. Again, you can't see the thing. There's an attractor in the middle. When they're far away from it, they get attracted to it. If they get too close, they get pushed away. And so we can kind of see that both of these guys have that back and forth movement. But if we look at it, if a mover comes in with kind of a more shallow trajectory, it's going to have more of a circular motion. I think that's what's going on. If they have a shallow trajectory, about half of them did, then we saw that they just end up as that inner circle changes its diameter. I think as it's beginning to shrink, then these guys just enter into a circular pattern where the ones that come in at a sharper angle keep bouncing up and back and forth and so forth. And so I just thought that was interesting, and then in kind of investigating that and playing around with that, I ended up getting this idea where I've got kind of a design being made, and I came up with some really what I thought were interesting designs just by letting these guys. Okay, here's another one. You've seen this one. I showed it to you guys I think last week, but this one just has a ship, and it's just following the planet. The planet is repelled by the ship. If the ship gets too close, the planet morphs to a different spot, and I can slow the ship way down. where I can speed it up. And I'm not actually changing its speed with this slider. Oh, can you guys even see the slider? The slider is actually changing the max speed. So acceleration keeps adding speed, and this will allow it to increase. Okay, in this one, this is starting off before, but in this case, only one of these movers is being attracted to the green mover. The green mover is changing its direction every 5 seconds, I believe, and only the red guy, so all of these guys are in the same array. The green guy is at index 0, the red guy is at index 1, and all of the others are in this array, and they're simply being attracted to the mover that came right before it. So if I have a mover at location X, then it's being attracted to the mover at location X minus 1. And so I got this interesting idea. Now I started playing around with this and just trying different things. So we're just experimenting and trying different things. You've got to take the idea of attraction and then apply it in some way of your own. And so then I thought, well, what happens if I just kind of shrink it down? Instead of drawing circles, I drew lines between the two movers. And so that was different. And let's go ahead and see what that looks like. If I go ahead and change this, I think it's mover 5. And so I just kept making changes and ended up coming up with this guy. And this guy is way too long. So I'm going to go ahead and shrink him down. Oh, this also, let's see, I think if I change main in this guy so that he is only moving, let's see, we're just going to make 20, let's make 30. So if I just make 30 movers, this thing will begin to look more like some kind of snake creature. Okay, that didn't work. Let's see. If I got the wrong, let me just check and see. Oh, I didn't save it. So that's one thing. And let's check the index. So I'm just calling main, and so main here is 30. Yeah, that should work. I guess I just didn't save it. So here it goes. We'll take one more look at this guy with just 30 segments. Yeah, that looks better. And so these elements are just going to have one void, or one mover is just going to be attracted to the mover ahead of it, and you get this kind of weird snake thing. We are coincidentally going to be doing a snake lab at some point later on in the quarter, but it has nothing to do with this. This just happens to look like it. In any case, I just thought these were interesting. These are different ways we've used the attraction. I can begin to think, how can I use attraction to create creatures in my ecosystem? So every time we do a lab, we're kind of giving you the code and telling you to do the lab, and then you've got to take that and apply it in some new and creative way. So that's what we're doing at this point in the course. That's it for tonight. Bye-bye.